Steal one of that jerky.
So people on the phone, you can hear me speaking okay?
Yep, loud and clear.
Okay, great. So before I get started in the formal talk, I just wanted to tell a bit about how I got so into Power BI. And it started out in Germany. So this is a picture of my family when we moved to Germany. We had intended to stay in Munich for just 2 years, and we enjoyed living in Europe so much we ended up staying almost 5 years. And I pretty much had the same job at the beginning that I did at the end. I moved up from covering Europe to Europe, Middle East, and Africa, and then to Microsoft International for the services controller position within finance. So I was worldwide except for US and Canada, but essentially it was the same job managing a bunch of controllers. And so in the last year, I was pretty bored, and I started teaching myself about Power Pivot. And Power Pivot is a technology that came out about 10 years ago. And it is the ability to join together different data sources to create a single data cube. And it was designed in such a way that analysts, as opposed to SQL engineers, could use Power Pivot. So I really invested about a year understanding how to create data models and how to create them from a variety of different data sources, whether it was SQL, CSV files, Access files, or Excel files. And because I was teaching myself, I just had to figure out things on my own, how to create joins between tables, how to use Excel in order to develop dimension tables, etc. And that kind of really gritty hands-on experience has been very useful here because our data is so dirty. And so the techniques that I developed to create workable data just on my own are, I think, quite applicable here for what we're doing at Kensai. So we're going to go through some of those techniques and what that looks like. I wanted to start out thinking about things on a theoretical level before we dive into actual hard skills. And so I wanted to start out with developing an analytical and visualization framework. So something that we can all align on as an organization to really be speaking the same language and understanding the same concepts. Question?
I was going to ask if we could record these.
It is being recorded.
Good, awesome.
Okay, so let me change the slideshow on current slide. So we're going to spend the first day just talking mostly about concepts. If there's time at the end, I will show you how I work with these concepts using Power BI, but mostly this will be a theoretical conversation. So when we're talking about building a data set or a data model, there are 4 basic factors to this. The first of these is just your data itself. So these are fact tables. So when we import a data set out of an EMR and into SQL Server, those are fact tables where we're looking at things like patient ID numbers and length of stay measurements or readmission measurements, etc. Fact tables, there can be many different fact tables. So one could be a fact table for encounters and what an encounter is like. The other could be a fact table for patients and patient histories. We need to find a way to join those different tables together. So the way you join those tables together is creating dimension tables. And dimension tables focus on, just as the name implies, one specific dimension. So there can be a dimension table for time, or a dimension table for geography, or a dimension table for DRG, etc. And by creating dimension tables, that allows me to join, for example, the encounter table to the patient table through these various dimension tables. So a dimension table has to have a column of unique values. So one example of that could be months of the year. So if we have January, February, March, April, May, June, all 12 months, each of those months in a dimension table can only appear one time. But I can take that dimension table and then join it to a fact table where the value for January can appear many, many times. So for each dimension, you create a column of unique values that allow us then to join fact tables together based on those dimensions. So dimensions are very similar to categories, what I just described: facility, DRG, time, and geo. And as we are building up our fact tables, we're conceptualizing, this is part of what we're doing when we're building out a data contract, is figuring out which dimensions or which columns do we need to bring into our fact tables in order to provide the type of information we need. Okay. So we focus a lot on categories. The third element is measures. So these are from an Excel perspective, these are formulas. From a SQL perspective, these maybe I'm not a SQL guy, but I think these are calculated columns. And examples of measures are things like actual, budget, year over year, or top end, and there are hundreds of different measures. One of the things we're going to focus on is the difference between a calculated column and a calculated measure. And you in particular need to think about it. Yes?
Difference between a fact and a measure.
A fact, when I say a fact table,
Yeah.
a fact table is a table of data.
Okay.
From that, we elicit a fact. But a measure is a way of pulling out a fact. So you can say, what is a fact? I would say, well, actual expenditures were $1 million. That's a fact.
Okay.
Provided our data.
And so a measure could be like the standard deviation of something that was consumed in a fact table.
Correct. Yeah. Yeah. So if you're thinking in Excel, a measure is a formula, like A plus B equals C. Now, there are two different types of measures. The first measure is a calculated column. The second type of measure is a calculated field. So if you think about two columns of data, let's say one column with actuals and one column with budget. If you're building a calculated column, you would add a third column in. And that the action would be actual minus budget equals the variance to budget. And this is performed at the row level within the data set. So with each row, there's a calculation. A measure, a calculated field, what I'm going to call it a measure from now on, takes an action on an entire column. So the sum of the actuals column, we would just call it actuals. The sum of the budget column, we would call it budget. And it's performing an action on a single column. And once I have that measure written, then I can do a lot with it. So if I have the actual sum and the budget sum, then I would calculate actual minus budget to give me variance. And spending some time thinking about this, and there are a lot of great articles on the internet about the difference between calculated columns and measures. Really understanding this is awfully important because it leads to much more efficient data models and much more flexibility in terms of what we write. And I think for SQL people, your initial inclination will always be to go to a calculated column.
Oh, yeah.
And it's the wrong thing to do.
Get it.
You should have 90% measures, 10% calculated column. One is for efficiency, two is for flexibility. And then finally, taxonomies. And taxonomies is something that we have not done well at Kensai. Taxonomies is, Carly's heard me harp about this for a long time, so I'm glad to be able to do this formal. A taxonomy is a way of classifying things, just as its use in science implies, right? It's you think about genus, phylum, species, etc. Taxonomies are applied to any dimension. So if we think about a time dimension, we can have a single day as the most detailed aspect of a time dimension. From that, we could go to a month. From the month, we could go to a quarter. From a quarter to a year. And if you're getting really big, then you can go from a year to a decade. And then you can think about DRGs in the same way. At the IDC 9 or IDC 10, there are thousands of them. Then the DRG, there are 900 or 700, something like that. There are the MDCs, or the major diagnostic categories, and there are 25 of those. And then I sat with Steve, and I had him help me produce the super category, where I ended up with a grouping of 5. The reason why I believe this is so important is because it allows you to create logical paths to drill down into the data. And so if we are, for example, trying to identify outliers, if there are thousands of diagnoses, identifying one of them as being big could be interesting, but it doesn't give you a meta message. Whereas if we start out and say in major organs and systems, with the super categories I created with Steve, we're able to start out there and say, wow, the risk of readmission is higher, or this 1 out of the 5 groupings, then that's something pretty major, right? And then we're able to go down from 5 to 25 and see within major organs and systems, where is the variation coming from? And from there, we'll go down to the DRG and see where the variation is coming from. And if we really want, we go all the way down to the specific diagnosis. And I think too often, if we look at the Power BI files that are created here, you have a tree map. So a tree map is where you have all the little squares. And oftentimes you'll see tree maps where there are hundreds of little squares. And that's because there's no taxonomy to drill down into. So one of the things I think we need to invest our time in is to create standard taxonomies that we just apply as a matter of course. That when we're building out our data models, we bring in these taxonomies to enable drill down. Any questions about that? Okay. So when I'm building a data model, there are three things that I'm doing. One, we're all doing, is we're figuring out what data do we need. So this is the data contract. And we're pulling this data out of an EMR or another source system, either as CSV files or SQL files or Excel files. So these are the different fact tables. And these include, we should include only the required columns from the bottom level of the hierarchy. So one example of this is if we're looking at data by date, so July 1st, July 2nd, July 3rd, there's no need to pull in a month column. There's no need to pull in a quarter column or year column. We would just have the day column. Similarly, if we're looking at data by DRG, there's no need to pull in MDC on top of that. Or if we're looking at data by zip code, there's no need to pull in state as well. Because we want to keep our fact tables as small as possible. So Power BI works very well when it has many rows but fewer columns. The next is to join these fact tables with dimension tables. And when I have a brand new data set, say I have a single fact table, a lot of what I will do, I'll spend my time doing is understanding what are those dimensions and creating dimension tables. And when I create a dimension table, I'm also creating a taxonomy to go along with that dimension table. So for me, a convenient way to do this is in Excel, where I'll just pull in a column and understand what is that column trying to do? Are there related columns within the data set that I should also have? And then I'll build up dimension tables along every single column that I can in order to join two or more data sources together. And then finally, I write the formulas that I need in order to make this data workable and understand. So formulas, again, being calculated columns or measures. And there's this book, Power Pivot Pro, that I've been showing to some of you. I suggest that you guys get the book in hard copy form because it's so great at explaining DAX and how to use DAX. And I'll write it tomorrow and show you that book. But I still have 3 copies of that just keep going. One at home, one here, one for extra special. Okay? So I've already explained the difference between columns and measures. Any questions based on what I've talked about so far? Okay, very good. So these are examples of categories and measures. And we can think about, when we're looking at categories and measures, what we're trying to do is variation analysis, right? You guys say, I mean, as a company, we've already clued in on how valuable variation analysis can be. So we look at variance across categories. So in this example, product or channel, or across time, geographies. We look at relationships between categories. So let's say, if we group patients by age, are we seeing a certain trend within a DRG by age? So are people age 65 to 75 experiencing more diabetes than people from 75 to 85 or from 45 to 55? And then, of course, variation across time. I think what I've noticed, particularly in the data that we're trying to get from Definitive, is we will really increase the value of our analytics when we're able to provide analyses across time. And that's been a weak point for us so far. And then measures are when you have a column of data, meaning a numerical column, that's when you apply a measure. So you apply a measure to that numerical column. Examples here coming from finance are actual, variance to budget, year over year, budget, etc. So those are the measures. When we're thinking about what are we going to put on a page and how is that page going to help us understand what is going on with our data, it helps to be deliberate in thinking about what goes on. So one example is you would look across one measure for many categories. So for instance, if we're looking at rates of sepsis, so rates of infection, we would look at it by age group, by hospital, by diagnosis and understand from all those different perspectives what is happening with rates of reinfection. And by playing with one, we can see the impact on what is happening with the others, right? So if you have all of these different dimensions and the only measure you're looking at is infection rate, then you can see, well, if I select acute care hospitals, then I can see whether that's higher or lower across different dimensions, et cetera. The other way to look at it is one category and many measures. So let's say we want to look at a hospital and how a hospital is performing. We would look at it by, we could look at revenue performance, we could look at risk of readmission, we could look at left without being seen, and we would be able to get a lot of information about a particular hospital. And by being deliberate and thinking, what are we trying to get out of this page, and what message are we trying to deliver, that can provide guidance into what should actually go on the page. Questions here? Okay, on the phone, any questions?
I'm good.
Okay. All right. So here's an example of now what is taxonomy? What are taxonomies? So we have times. The highest one in this list being year, followed by quarter, followed by month, followed by week, followed by day. And we could even go further, and we are in, for instance, when we're looking at Evergreen Emergency Department, we're looking on an hourly basis, right? So we're going at 15 minutes, actually. So we're going much deeper into this time frame. Geography can also be very high or very low. And then diagnosis. So here's an example of this table shows the MDC. So those are the 26 different major diagnostic categories covering the DRG. So let's pick MDC4. That covers the DRGs 163 to 208. So any DRG between 163 and 208 is part of the major diagnostic category 4. And then the name for the MDC number, so that's MDC category, is again number 4, D&D respiratory system. So when I sat with Steve, because I wanted to have to represent fewer boxes in, say, a tree map, I didn't want to have these 26, I wanted to have 5. I sat with Steve, and he helped me to group them together. So you can see 4, 6, and 7, or respiratory system, digestive systems, hepatobiliary systems, and kidneys. Those were major organ systems. And Steve helped me to group those together in a way where a physician wouldn't look at this and what moron put those together.
Still might say that.
They still might say that, but at least I can say, well, I had a doctor,
I know the moron.
I had a doctor help me, right? So it wasn't just me being clueless on my own. But again, I think building up these taxonomies so that we can drill down in a logical way makes it easier for our customers to consume what we give them. And then when we're talking about how to look at data, there are really 4 ways of thinking about it. And actually, it was interesting. When I built this slide, I was less familiar with data science and machine learning predictions than I am now. But it turns out these 4 ways of looking at data are also the 4 ways you can use ML within Azure Machine Learning Studio. So these are the 4 groupings of experiments. But you look for patterns or relationships between. That's the first one. The second is you look at trends over time. So what is happening over time from an actual perspective or a variance perspective, etc. You're looking at comparisons and deviations. So, what things are like each other, what things are different from each other. So how can you classify and group things? Which group of hospitals are performing well on length of stay versus which are not performing well? And if you want to focus in on those that are not performing well, what commonalities do they share? What differences are there?
This would be a good slide for us to use for the acute ML, which is how we explain ML to people outside of the company.
Yeah.
This would be a helpful slide to talk about.
And then outliers. So what one or few things are like each other or different from each other. So as you're thinking about a slide and what do you want to show on the slide, you can also try and plug into which type of analytic are you trying to run after? Are you trying to identify outliers? From what dimensions are you trying to identify? Or if you're looking over time, what should you include to get a best understanding about what has happened over time? And so this can include types of visualization, but also the types of measures that you've written in order to elicit change. Yes?
What's the difference between a trend and like deviation? Seems like they kind of tend to show us almost the same.
The trend and the deviation?
Right. Or is it more?
Well, so a trend is usually something that's happening over time.
So it's always trend is always based on time.
I would say trend is always based on time. Whereas comparisons and deviations don't have to be, they're not time. They don't have to be time-based. And then there's a workflow that takes place when you're looking at a data set in order to come up with meaning and understanding. So first, you just have to figure out what do you need and how do you put it together. And so when Carla and I were building out the first variation analysis, we spent a lot of time just doing this. What do we have? How do we get this data from definitive? And what do we need to do to clean it up? One great example of this is the Excel tables come in from definitive, and they have hospital type. And hospital type can either be hospital or health system. And we didn't understand the difference between those two. It turns out health system is a summary of hospitals. So for instance, if you're looking at admissions at the hospital level, and you have 10 different hospitals, the sum of all the admissions to those hospitals is 1,000. There was also a row in there that was equal to 1,000, and it was health system instead of hospital. And so in essence, we were double counting the number of admissions. And this highlights the importance of understanding your data in detail so you don't have screwed up things like this. So imagine going in front of a customer and saying, here's how many admissions you have. And they said, well, that seems a little high. In fact, it seems pretty close to, double. And so you go back and look at it and say, damn, it really is double because I didn't spend enough time looking at my data to really understand it. And so it takes a ton of time to do this, right? And this is something we all know. Data prep takes so much time. In part because it can be dirty, but also in part because we need to educate ourselves about the structure of the data and the data itself so that we're not making stupid mistakes. The second is grouping together facts, identifying things that should go together. And again, this can take a lot of time. So when I went to, let me go back, when I made my own first run at the MDC super category. And that was just me as a total layman, but trying to put things together that made sense. And happily, Steve only had to correct me, for 80% of what I did. I got 20% right for first. But it is understanding the data and figuring out how does it go together, how do you fit it together. And again, that takes a lot of time. But once you have those, once you understand the taxonomies and how to drill down through the data, then you're really starting to get an understanding of what is going on with your data. So then I would take it and I would start to share it out to people and say, hey, Steve, here's what I noticed. Does this make sense? So one example of that is you guys know that I've done this work on data from the Center for Disease Control on people dying from opiates. So mortality rate from drug overdoses. And then for the MTC demo, I was looking at heart failure. And I noticed, pretty rough relationship geographically between dying from drugs and dying from heart failure. So I was all fired up about this. I went to Greg and said, Greg, look, they go right together. And Greg said, you're a total moron. They don't go together at all. They're minimally related, but it's not enough to predicate a demo on and have credibility. Good people do it. But that's the value of me identifying something and having experts nearby to go to and say, hey, does this make sense? Can you take your own decades of experience and help me understand if I'm onto something here or if I'm not? And then finally, once you've done that, then what is the right way to tell that story? So how do you use the visualization to tell a story effectively? And again, this is an area where at Tensai, I think we use visualizations in inappropriate ways many times. And I think we don't think enough about design and how do we put things together on the page in order to tell stories. And then a third one, which only occurred to me recently, is are we trying to enable discovery or are we trying to impart information at face value? So are we trying to have a dashboard where we just want people to see, hey, in the ED, we have, now wait times are at 90 minutes, so we want them to be at 35 minutes or less. And they don't want to go any deeper than that. And that will lead us to a much different type of layout than if we're trying to enable discovery. Where do we have high rates of readmission? By geography, by facility, by DRG, by age group, etc. And understanding, are we trying to enable discovery, or are we trying to just get factual information that can be acted on very quickly, will lead us to designing our interface in different ways. Questions about that one? Okay. So another important piece that I think we need to work on, and clearly there's recognition of this, is how do we present our findings to our customers in such a way that they walk out saying, this is a really valuable meeting. Not only that, I want to go further with Kensai because of what they've shown. So it means knowing your audience. So business leaders are pretty much the same wherever you go, is they don't have a lot of time. They're really impatient. They're always thinking about the political ramifications of what's going on. And, the countless examples that I've heard here, our customers are no different. They need to make decisions. So what we want to show them will enable them to make decisions. We need to be factual, and these people are mostly analytical. Sometimes they're not. Right? Sometimes business leaders are not analytical at all. They need to be told things. And so as we get to know customers, we need to think, what kind of person, individual is this, and tailor what we show and how we show to them in order to have it make the most sense and have it look good. And so when I was in Germany, I had this kind of 6-month transition plan. I was going to move back, and I was going to support the newly hired vice president of sales for the services business in Microsoft. I was all fired up about it because I had all these new skills, right? And they were so powerful, and I was so intrigued by them and enthusiastic about them. So I envisioned me sitting with this guy, and we change the business through analytics. Right? We sit down, we just be driving data together, and then we come out and make changes. This guy didn't give a shit. He didn't care at all. He was kind of like Trump, right? He wanted 3 bullet points and a map. And it was so disappointing to me that we couldn't do this. And then, there's this functionality in Power BI called Q&A, where you can type in a question and it gives you an answer. And so this guy, he got burned because of that attitude, because the leadership team of the service business at Microsoft was really analytical in nature, right? They were numbers driven. They remembered numbers, they memorized them. And in business meetings, they were calling up numbers, and they were accurate numbers. And this guy was a loose guy, right? So, well, I think we're up 5% in France for sales. And they said, no, in fact, we're down 7.3%. And pretty soon, he was losing credibility every time he went into a meeting to open his mouth because he didn't know what he was talking about. And it was really problematic for him. So finally it came and said, Jeff, can you help me out? And I created this dashboard with, say, 20 different tiles in it. They were all Q&A dashboards. So one would be year-over-year sales. And he could click in that, and then he could type in Germany or in France and get an exact number. And then he could say that and be correct and not appear like a moron. So finally, I broke through from an analytics perspective with him. I would have done this had I thought more rigorously about how he wanted to consume data. I could have provided that service for him much earlier. And so I think, as a best practice for us, we need to think about that exactly. Is who is our audience? How do we display information in a way that they're not only comfortable with, but makes them successful? So analytical guidelines. Start with the end, right? What's the end point? What is the end state? What are we trying to work for? Which decisions will this help to drive? What are the sensitivities and considerations of our customers? And how does what we build address those? What level of the business are they? And this one's super important, right? Is it the CMO, the CFO, the CEO that we're preparing this for? Is it a mid-level manager, or is it someone who's on the front lines? And that's going to impact what we show, how drillable we make it, how hard or easy we make it. And we do this with our persona. But I think it's a skill that can constantly be focused on. Think critically. This one is really important. So if we think about coming back to calculating columns, I saw one where So we had actual, we had budget, then we had a calculated column which was variance to budget, and then a calculated column which was the percentage variance to budget. So that was the variance to budget divided by the budget, calculated at the row level. And then to get the total variance to budget for the entire data set, this example, they summed up this column of the variance to budget percentage. Right? So we had a variance to budget percentage of 8,050%. Because they hadn't thought about the mathematics of this. Mathematics where you need to take the total actuals, the total budget, then get the total variance to budget, and then divide that total by the actuals. And or this example from Carly, where we were looking including health systems. We didn't know the data well. Match the graphic to the data. So there's one example that I've seen here several times, which is where there's this funnel graphic where you start at the top layer at 100% and then it gets narrower and narrower. But if it's not a real funnel, don't use a funnel graphic. Or if you want to look at understand percentage relationships, if you have a pie chart with 80 different categories in it, again, it's totally useless.
Just don't use pie charts.
Yeah, as a rule, don't use pie charts or don't use Excel. Because they don't impart a ton of information. Right? If it's 2 or 3 things, maybe you can get away with it, but beyond that, you have no sense of relativity. Simpler is better. It took me a long time to come to this one, but there should be fewer things on the page, and this is a problem that I see here is people are just cramming stuff all over pages, and we don't have it becomes so hard to extract a message, to get an understanding out of that page when there's so much going on. And so I've seen Dr. Nick and Dr. Greg working through one of the, I think, IU, and so it's a super complicated page, and they'll select something and say, okay, let's get a screenshot, right? So they'll take a screenshot of it, and they'll put it on a PowerPoint, and then they'll make notes about it. Because if they don't do that, they have no clue why they did it. So that's an example of something being too complicated. The message should jump out at you. Be consistent. Again, this is another big one. And for your story is a great story. When you were doing the first rev of Kaleidoscope, you had stuff all over the page.
Oh, yeah.
And Samir pushed back on this and he said, I want this to be what an executive would look like. And so it was redesigned. So there were KPIs going down the left side, filters up on top, and 2 or 3 visualizations in the middle. And that simplicity and consistency is what satisfies it. Any comments on that?
No, that is about like basic usability and basic user experience requirements. I know that Sylvia's been working on that for us, but for those of us who are engineers, I'm like, yeah, it's totally logical. Everything you need is on the page. You just have to go searching for it.
Yeah.
And that doesn't resonate well with particularly users who are very data-driven and just want the answer. They're not going searching for it. And so that was a big transition. Is we're not making this is important. We're not making these for ourselves. We're making these for our users, and that is a big hurdle.
Yes.
And again, the users change.
Yes.
Correct. Yeah. And so it's the cool thing about Power BI is the data is the data, right? And it is very easy to create something at a very high level and also something at a very detailed level for different users because the data still remains the data. So this next one, use edit interactions. I'll show you what that means, but I won't go into detail here. Formatting drives understanding. This one is so important. When Augie and I were working on Evergreen, I was a little irritated at how exacting he was. But despite, I've had this slide for a while. I know the importance of this, but sitting together with Augie repeatedly and focusing, hammering on, we got to a point where it really looked good, right? It was really appealing. And that in itself has its own power, right? When I was at business school, there was they split us up into work groups, so teams of 5 people, and every night we met from 8 till midnight, pretty much, to work together. And it was this conglomeration of totally different personalities. The smartest person in the room was this woman from China who was an engineer, absolutely brilliant. When we did Excel stuff, her files were incomprehensible because she would do calcs and have 20, after the decimal point, 20 different values. and no comments, right, to break up the number. And I used to go crazy looking at her output because it was just so hard to see. And that was the first inkling to me about how much formatting impacts understanding. If it's simple, if it's clean, if it's consistent, it facilitates someone's ability to consume it and understand it. And so we need to be really aligned on what colors are we using, what types of graphs are we using, how many elements are we putting on the page. And this is where Sylvia's expertise really is going to help us, because she's going to help us get to a super professional level. And this will absolutely differentiate us from comments. So we're now to part 2, storytelling with data. So would you rather see some examples right now of what I just talked about, or would you rather have me move into this storytelling with data? I think I'm going to go to examples. Okay, so we come to Power BI. Power BI is Microsoft's data visualization platform, and I know this is probably a review for most of you. I just want to set a little bit of context. So Power BI has 2 main products. The first of these is Power BI Desktop. So Power BI Desktop is what you should have on your computers for tomorrow's exercise. It is an authoring platform. And Carly, if you don't have it, you need to get some help to get it, because I can't help you with that. Okay. But it's just like Excel, right? It's an app, and it's where we do authoring. We can write measures here. We can bring in new data sources. We can update data sources. So this is where all the creation takes place. The Power BI service, which here they're calling Power BI Premium, is where we publish out into the cloud and can consume it through a browser, either on our desktop or on a phone. We can share it across large audiences. And this is where we also can refresh it, set up automatic refresh. So this is what we're going to be working through for Evergreen, is how do we update this every 15 minutes and have this live dashboard. We've not done that yet here at Kansai, and to be honest, I've never done it either. But I mean, this is now making data really live. We have used Power BI Embedded quite a bit. So Power BI Embedded is the ability to take a Power BI report and put it inside of an iframe. So that means it can be inside of an EMR, it can be inside of a web page, etc. And this is where Nabil is the resident expert for that. And so what mainly think about Power BI Desktop for authoring, and then different elements of the Power BI service, which is where people. So I wanted to show you how to work through these concepts that I talked about. So how to get fact tables, how to bring in dimension tables, how to write calculated columns and calculated measures. And that's where we'll end today. So here's Power BI Desktop. We can get data from many different sources here, right? So Excel, text, CSV, so flat file types, JSON, databases from Microsoft, but also third-party Oracle, IBM, Sybase, and Teradata, SAP HANA and Business Warehouse, Google Analytics, all the different Azure connectors, Dynamics 365, Salesforce, obviously, of course, right? So dozens of different data sets. We're going from Excel. So I'm going to connect to the Excel file and then navigate to my Microsoft, my Excel file. I open up the file, and inside the file, I have a bunch of different tables. So a table is a named range. And let me explain what that is. So take this is a range of data. It has 2 columns, month name and period. And then I've highlighted these and said insert a table, and then I name the table, and so here I name it period. And then in this one, I've named this one date. In this, I have hospital. So this table name is hospital, and all of these columns are in the hospital. You can tell it's part of the same table because it's colored. And so now when I come to Power BI and I select a table, you'll denote, a table is denoted by this blue line on top, as opposed to a sheet in Excel, which has no blue line. And so if I select a sheet in Excel and I have many different elements on that sheet in Excel, it's really going to confuse Power BI. Here, I have discrete names for each table. And I could have a number of different tables on each sheet, but I've given them discrete names. So I'm going to select prior revenue and current revenue unpivoted. Okay? And I'm going to edit them. So This edit piece is called Power Query, and it's available in both Excel and in Power BI. Tomorrow we're going to do all this together. This is a preview of what we're doing tomorrow. So in the prior revenue, I have dimensions. So I have a date dimension by day. I have an encounter ID. I have a type code. So this is hospital type. I have an insurance company code, a DRG code, a location code, period code. So these are our months as opposed to dates. And then I have just one column of that, so prior year revenue. In the current revenue, I have the same dimension columns, but there's a crucial difference between these two columns. And that is each month has its own column. And so the structure of these tables is different. Now, before Power Pivot came along, this is Power Pivot's Power Query technology. Before this came along, I would have had to solve this problem in Excel by copying these dimension columns down 12 times and then moving each month over and down 12 times. Now, someone in SQL could have done this. You can write formulas in SQL to unpivot things, but in Excel, you just do it by hand. Power Query allows me to do a lot of changes to this data. So here, I highlight 12 columns. I'm going to right-click and unpivot the columns, and just like that, I now have a single column for my data. This column is called period. It's the period column. So I'm going to rename this, call it period. I'm also going to change the type from text to number. So I know it's text because of the ABC right here, and the fact that the numbers are left side of the cell, just like in Excel. So I'm going to change the type by coming down to change type, whole number, and rename this, and just call it current year. Okay. Yes. Okay, so now I'm going to close and apply. Now, these two fact tables, these are fact tables, are being brought down into Power BI Desktop, and now I have the tables. So these are the same columns we looked at. When I go from the data model view, or the relationships view, to the data table view, here are the actual data tables. So this is pretty cool. I have my two fact tables. Let's try and join them. So I'm going to pull type code over to type code, and they won't join. And the reason why they won't join is because one of the columns must have unique values, right? So for instance, let's pick another one, period to period. When we do that, we get the same message. The columns must have unique values. When I come back and look at the tables themselves, if we look at the period column, you'll see many ones, 2 12s, a bunch of 2s, a bunch of 3s, etc. And it will be the same thing in the prior revenue table. Let's do sort ascending. 1s, and then if we scroll down 5,000 rows, we get to 2s, etc. Right? So I can't create a one-to-many relationship because I don't have a one side. So let's go get a one side just for period. So when I come back, now recent sources, practice tables V4, and when I come to the period table, and it's going to give us a preview, January and period. So I want to edit these. So I'm going to select this table, edit this table. And I don't need to do a ton here, except I would much prefer things in Power BI to be short as opposed to long, just because it takes up space. So I want to create capture the first 3 letters for January, for February, for March, etc. I'm going to do that through this add a column function. So I'm going to add a column from examples. Okay, and I'm just going to type in Jan, hit enter, and it's going to look across and try and identify a pattern. It doesn't have enough yet. So then I'm going to say Feb, and now it's correctly identified. So then I click OK, and now it's automatically creating this. This is super cool. Then hit home, close and apply. And so now it's going to bring the period column in, or period table in, and let's see if it did the join. It did a join on both tables. I automatically did a join, and the join is coming from period, period, and here period to period. So now, if we're trying to look just along this time dimension, we can now look along a time dimension in both tables. So let's go ahead and do that. So now I'm going to write some DAX formulas. And the first formula will just be to sum up prior year revenue. So I'm going to write, will be a column or a measure?
It's probably not going to be a column.
Excellent.
Yeah.
Okay, so I'm going to write a measure, and it's just going to sum up this entire column of prior year revenue. So prior year rev equals, and this is just like Excel pretty much, the sum of the table name, which is prior, and I'm just going to go down and get prior year revenue. So the table name in the column. And this is the first measure. Second measure, we're going to come to current revenue and write the same thing. So a new measure. Well, okay, now here when I look at this, I notice something, and that is that the current year revenue is it's a text column. I know it's because it's left oriented. So this means I can't deal with these as numbers, but I can go back and edit the queries and come over, and this is going to be. So in current year revenue, scroll across and see it's ABC or 1, 2, 3, which means it hasn't identified it as anything yet. So now I'm going to change the type to whole number. Okay? And now I know it's going to be a number. All of these steps that I'm doing are being recorded over here on the side. And if I want to look at the actual code that's used to do this, this is the code. So this code is called M. The language is called M. I don't need to know this. I just need to be able to work with this interface here. But what this provides is a way for us to show our customers or to show ourselves what transformation we have made to the underlying data. And for auditing purposes, this can be really important. So, particularly with finance people, this is a super important function. But you can do a lot here in Power Query. So I close and apply. And so now, changes. So now let's get current year revenue, writing the measure. So current year rev is the sum of the table name and the column. Okay, and now we can come down and I'm going to come back into the prior table and I'm going to write a third measure, which will be the year over year. Okay, so year over year equals current rev minus prior year rev. Okay, and so now let's get a data card, and so we're going to pull in these three values. So current year rev, prior year rev, and year over year. And so because format is so important, I'm going to add in commas here. So we have 2.5 billion in current year revenue, 2.46 in prior year revenue, year over year of 40 million. So now let's bring in some time dimensions. So if I bring in period, let's look at month name, characters, which I'm going to rename month. Okay, so now I have month, and one thing that jumps out at me, what do you guys see that looks stupid here? Order.
It's not normal.
The order of months looks stupid, right? It's alphabetical. This sucks. So I'm going to come back into period, and I'm going to highlight month, and I'm going to sort by column, period. So now it's going to sort based on this column. So when I come back, now we have January through December in the order that we wanted. And so now I'm going to change this graph to a bar chart, the table to a bar chart. And so now we're looking at the variant or year over year by month. And if I select July, everything is going to change to show July. So, and we could just do math here. 224 minus 182 is indeed 42, right? But it's working along this time dimension. Let's see if it's working along other dimensions. And the answer you guys should know is going to be not, right? So one, we don't have any dimensions in. But if I wanted to look at, let's say, location code, I'll pull that in. And it doesn't make any sense. Right? Nothing here makes sense. So it's affecting, because I brought in location code from the prior table, it will affect the prior year revenue, but it won't affect the current year revenue. Because I'm only looking at one side of the relationship. Right? So now let's bring in some other dimensions in order to enable us to do analytics from many sides. Does everyone catch that? Maybe I didn't explain this. We don't have a dimension table to support looking at location from both of our fact tables. So that's why when I select 1 month in here, or one location, the 2.5 billion doesn't change.
We use SQL. SQL does this automatically, right? Is that what I'm? SQL do the mapping.
I don't know. I'll ask the SQL guy. I don't think SQL does that on that.
You have to tell it to do it. It's right.
You have to divide, okay.
I have a question.
Yes.
In terms of so I'm looking at the fields. Some of them have a little sigma and some have a little calculator.
Yep.
What's the difference?
Great
between
point.
those icons?
So sigma is a numerical column. The calculator is a measure.
Thank you.
And if I were to add and so here's a date icon.
Yes.
Right.
Perfect.
If I were to add a calculated column, you get slightly different icons. So let's see that. Let me add a calculated column. So let's say new column. So instead of new measure, we get a new column. And let's say we're going to look at, we're going to group calendar year revenue into revenue where each row is greater than 1,000, right? So is if table name current year revenue is less than 1,000, then I'm going to say less than 1,000 as text. Otherwise, call it greater than 1K, just to be clear. Greater than 1K as text. Okay, so now this action is being performed on each row of this table. And this is chewing up a lot of RAM. It's chewing up a lot of memory, which is one reason why you avoid calculated columns. Is it really eats memory. And it can make what should be a really fast file and really slow file.
So what is an alternative to that? Because I mean, for me, coming from super Excel user type world,
right,
we would do that a lot. But I realize it's difficult here. I mean, obviously with the size of data that we're working with, that is not an option.
So this is a great discussion for us to be having as a company is what should the development cycle look like as we're building out data models for customers. And Power BI Desktop is a great tool for doing stuff like this and figuring out what we want. Then we need to go back to the database guys here. So I would go back to Chow and say, hey, Chow, look, I have this calculated column. It's really important to me. Can we incorporate this back into our SQL table? So can you write the SQL code to give me this so I don't have to do it in Power BI?
Number one thing I was finding myself doing is joins. Like for this DRG, get me the GMLOS. That I was using columns for, but there's a way I could probably do that with a measure, right?
Well, or where you do it with a dimension table. So can you map dimension tables to GMLOS?
Yeah, it would be the delta between a GMLOS and some other number. So I didn't just need it, I needed it in a formula.
Yeah, so many times you can do stuff like that just using measures, not using columns.
Okay.
Yeah.
I just need to learn that part too.
Yeah, correct.
Okay.
Okay. So now we can go back and get more dimensions. So come back to recent sources, practice table V4, and we'll bring in DRG, hospital type, insurance company, and MDC. So these are the rest of our dimensions. I click load, and now it's going to bring in all these tables, and it's going to look for the joins just like it did with period. And let me rearrange these so we can get a look at them. Okay, so a few things are going on here, right? In many cases, it made joins correctly, but in some cases it did not make joins correctly. And let me explain what I mean by that. So the DRG table is a table of DRGs. The MDC table is the major diagnostic categories, and it's the one that I worked on with Steve where I created the super categories, or we created the super categories. So it did a join from the MDC table directly to the current year table, where I had an MDC column, and directly to the, it didn't do a join in the prior rep table. What I really wanted was to have this join be going from the DRG table to the MDC table, because I want to modify the dimension DRG with a further dimension MDC. And it didn't create the data model I wanted. Anytime I look at a data model in Power BI and I see these dotted lines, it means the relationship is not active. And so it's a useless join. But it also means whoever designed this data table does not have a clean data model. And I hate getting this because then it means I have to go back in and redesign everything to make it clean. So one reason why this happened is because I didn't specify in options when I'm doing the data load. I can select or deselect auto detect new relationships after data is loaded. For a simple data model, it's okay to have this auto detect. For a more complicated model, I would turn this off. So every time you bring in a new table, you don't have to undo joins that have been made out of it. But here, I'm going to undo this join between MDC and current year red. So I'm just going to delete the join. And then I'm going to double click into the inactive join and make it an active join. When I do this, now I've joined these two tables. And this is a snowflake pattern of joins. SQL people will not be pleased with snowflake style data models. In Power BI, it's okay to do. It's fine to do. Okay, so don't be too upset about that. Okay, so then we have the insurance going from insurance code to insurance code. Hospital. Okay, so hospital join. So I'm going to delete the join between hospital and hospital type. We need to end. Okay.
Yeah.
So
Sorry.
let's pick up here tomorrow, guys. We're at hours in. Was this useful?
No, we're interested.
I'm just gonna grab my mic real quick.
All right. So people on the phone, any questions? All right. So tomorrow,
Thank you.
I'll share out this file with you all, and we're going to build this together.
Doing it live. Thank you very much.
All right.
Excellent.
Thanks, Jeff. Thanks, Jeff.
That was awesome.
Good.
As always.
Looking forward to more.
All right.
Expert update.
Yeah.